Okay, first I check calibration of probes. Both probes. Press auto. I also have the choice right here to get more on there. I can shrink that down, move it up. Very nice waves. Alright, I'll check the next one right away. Okay, here is channel 2 probe calibration. Looks good. Okay, now. Okay, excuse the sound of my jet heater in the background. You should still be able to hear me good. Now, just with one single probe, I'm just real quick checking to make sure here our voltage, 16 volts. Now I just have this connected directly to our probe here. You could see down here is our frequency, volts peak to peak. So that must be what the frequency generator is putting out. We're measuring in RMS. So this is what we're going to be using. Here's all the other readings up here. You can see our frequency generator does actually have a little spike in those corners there. As I know this probe is calibrated. Alright, next. Okay, quickly going back to checking the output of this frequency generator. I did just happen to notice voltage amplitude. Right, we do adjust amplitude. Huh. What's the difference between amplitude and peak to peak? But anyhow. Okay, so now we're going to do a little test. Here's our frequency generator again. And we're just hooking it up to these two resistors, 100 ohm and a 0.1 ohm. Now we're going to hook in two of our probes. Okay, so now I hooked our probes into our test circuit. Here is yellow probe, probe number 1, channel 1. Our voltage probe, it's right on the positive and negative side of our frequency generator here. This is a 100 ohm resistor, known resistance. This is a 1 ohm. Now you may have noticed I switched out the 0.1 ohm. That's because the math comes out differently. This is our second probe, just going across a shunt resistor. Now this is at 1 times. This one is at 10 times attenuation. Alright, let me show you that real quick. Where are we? Here's our voltage, our current, as we're calling it, and our average. Now I just stopped the running on here, so it's paused. Let me show you. This is the difference. This was when I had the 0.1 ohm resistor in there. Okay, we had 5.4 volts divided by 100 ohm resistor, 54 milliamps. Probe 2, our current probe is 1 times. We had 65 millivolts or milliamps, whatever you want to call it. 65 volts, 650 milliamps. And then we go to our maths, which showed 80 milliwatts. And we do our sanity check, as we call it. It's our watts, or power, equals 5.4 volts times our current equals 3.51 watts. And I know that's not correct. Our frequency generator can't even put out that much. So anyhow, moving along quickly here. This is what we have right now with the 1 ohm resistor. What I just showed you was the 0.1 ohm. With the 1 ohm resistor, now you can see at the end, this is what we have, 291 milliwatts. And if we do our little Ohm's law here, power equals 5.34 volts times the current, 336 watts. Now this is a lot closer. I think this is good. So I'm going to move on, and now without changing anything, we're going to see at our voltage everything the same, and we're just going to switch it over now. Okay, you can see we got all our LEDs lit pretty good here. Now here's our frequency generator. Splits apart right there. Here's our pause. The lights are flickering right now. I got a little weak connection. There we go. Positives right here before our primary. The negative of that comes over here to our 1 ohm shunt resistor. The negative end of our frequency generator. And that end of our generator comes over here. And here's our current probe, the blue one. That's just connected right across that shunt resistor. And here we are. I did change this 10 kilohertz, but that doesn't change our readout at all. Now this should be our real input power right there, guys. There's our voltage. There's our current. And we got about 200 milliwatts of power. 43 milliamps. This should be correct. Take this run stop button. Let's run. Now let me show you something else here. Oh, hang on. Okay, let's see. For viewing purposes, let's scale this current wave up a little bit here. And now I'm going to change the frequency here out of resonance a little bit. Oops, let's go this way. And it straightens out. And there you go. Now there, Don Smith and Rick Friedrich has mentioned multiple times about trumpet waves. There they are. But maybe I'm doing things a little bit better. So anyhow, yeah, you can see how that one goes. If I go up in frequency, back down in frequency, and we're still affecting the same corners. This is where we have the best resonance and the lights lit. We could also position that up there. We're getting it. I'm very sure and confident now. I'll wait to get some confirmation. Very confident that this is the correct readings. Again, I will wait for confirmation on that from some experts. And we'll be back with the next video. Don't miss us. Please subscribe, share, like, give it that old thumbs up. Thanks, guys. We'll see you again soon. There I am. Thanks for watching, guys. Okay, my LEDs are not that bright right now. Those are really bright over there. But I also have this 10-watt bulb in the system right now.